For today's lesson, we are going to discuss trigonometric functions, and I am your teacher for today. We're going to first discuss angle measures. So at the end of this lesson, you're going to convert radian measure to degree measure and vice versa. In geometry, if we're going to define angle, it is the union of two rays with a common endpoint. The two rays are called the sides of the angle, and the common endpoint is called the vertex. So if we're going to look at the figures 1 and 2, we have angle LMN. Same with figure 2 po. So, in this angle po, we have the initial side, ray MN, and we have the terminal side, ML, or ray ML. Same with the angle in figure 2. An angle is positive if the terminal side rotates in a counterclockwise direction. So we have a positive angle in figure 1 and a negative angle in figure 2 since the terminal side rotates in a clockwise direction. When dealing with angles in the Cartesian plane, an angle is said to be in standard position when its vertex is at the origin. So if we're going to look at the figure 3, so we have here B, which is located at our origin po. And and its initial side lies along the positive x-axis. So ray AB lies in the positive x-axis. In figure 3, angle ABC and angle ABE are said to be in standard position. So angle ABC and this angle is positive since BC or ray BC moves counterclockwise, while angle ABD is a negative angle since ray BD or sides BD rotates in a clockwise direction. Let's proceed to the angles in degrees. So if we're going to uh, uh, imagine the circumference of a circle divided into two 360 equal arcs. The central angle, that is the angle subtended at the center of the circle by one of these equal arcs, measures 1 degree, or written as 1 and the symbol of a circle at the top. The full circle then measures 360 degrees, and the measure of the semicircle is equal to 180, which is half of the full circle. And the quarter of it measures 90 degrees. So let us see figure 4. So here is the full circle. Quarter is 90 degrees, positive, going or moving counterclockwise, 180 to 170 degrees, and 360. Angle measures in radian. Aside from measuring angles in degrees, angles can also be measured in radian. So in a unit circle, 1 radian is an angle formed when the central angle intercepts an arc of the unit circle with length of 1 unit. So here is an example or an illustration of a 1 radian po. So here is the illustration po. An angle measures 1 radian. Next, we are to discuss on how to convert angle measures from degrees to radian and vice versa. So here is the conversion formulas, or here are the conversion formulas and how we can convert degrees to radians. So we must multiply, or we need to multiply the given degrees to or by pi over 180 degrees. To convert from radians to degrees, we need to multiply the given radian by 180 degrees over pi. And note, angle measures that have no indicated unit are considered to be in radians po. Let's try this example one. We have 160 degrees. So 160 degrees is a positive angle. And we have here pi over 180 degrees. So if we're going to convert this 160 degrees into radian form or radian measure, we will multiply pi over 180 degrees. So if we're going to simplify 160 by 180, so we can express this fraction in lowest term, 8 over 9, and copy pi. And then, don't forget to write um, rad, or the symbol for radian. We have also negative 300 degrees. So negative 300 degrees times pi over 180 degrees is equal to negative 5 pi over 3. So we can simplify 300 by 180. And the final answer is negative 5 pi over 3 rad or radian po. Let's have example 2. So we're going to convert 13 pi over 6 rad and negative 2 pi over 9 rad in degrees. So the formula in converting radian to degrees is by multiplying the given by 180 degrees over pi. So here is the solution for the two given mm, radian measures. So for 13 pi over 6, we multiply 180 pi 180 degrees over pi. So we can cancel pi and we can simplify 180 by 6. So it is 30, and then multiply by 13, the answer is 390 degrees. For the next example, we have negative 2 pi over 9 multiplied by 180 pi of 180 degrees over pi. So we can cancel pi here and we can simplify 180 over 9. So it is equal to 20 degrees. So, and then multiplied to negative 2, we have negative 40 degrees. And let's have now the right triangle trigonometry. So recall lang po natin yung ating angle kanina. So we have positive and negative angle here. At the end of this lesson, or at the end of discussing the right triangle trigonometry, you're going to determine the trigonometric values, the sine, the cosine, and the tangent of angles as the ratios of sides of right triangle. So we're going to recall the SOHCAHTOA. And we're going to solve problems involving right triangles. The word trigonometry is derived from the two Greek words trigonon meaning triangle and metria meaning measurement. So it is commonly defined as a branch of mathematics that studies relationships between the sides and angles of triangles according to Robert Coleman of 2015. As we have this figure 1 here and we have this acute angle here, we can have this following sides. The side opposite the angle theta. So ito po, opposite side of angle theta. We have the adjacent side of angle theta. And we have this hypotenuse, which is opposite the right angle. Here is an example. See figure 2 po. Ito po. We have right triangle ABC with angle C as the right angle. So here is the right angle. And we have two acute angles A and angle B. So let us determine the sides with respect to acute angle A. So if this is angle A, the side opposite is BC or side A. The side adjacent to angle A is AC or side B. And the hypotenuse is side AB or side C. For acute angle B, the opposite side is side AC or side B. The adjacent side to angle B is side A or side BC, and the hypotenuse is side AB or side C. For this example, we're going to solve the missing side. So if A is equal to 6 and B is equal to 8, find C. So we are going to recall the Pythagorean theorem to find the missing length of the side. So in this figure, C is considered as the hypotenuse since it is the side opposite 90 degrees or opposite of angle C. So in this case po, we are going to use C is equal to the square root of A squared plus B squared. So substituting the value of A and B, we have 6 squared is 636 plus 8 squared is 64. The sum is equal to 100 and the square root of 100 is 10. So therefore, if A is 6 and B is 8, the hypotenuse is equal to 10 units. For the next given, if C is equal to 15 and B is equal to 10, find A. So since C is the hypotenuse, so we're going to use this formula. A is equal to the square root of C squared minus B squared, where C is equal to 15, so 15 squared, which is equal to 225 or 225, minus 10 squared, which is 100. So 225 minus 100 is equal to the square root of 125, and its simplest form is 5 square root of 5. So take note po that the value of C here is the longest po. Let's have these definitions. So let's recall the SOHCAHTOA. So if this is the acute angle, we have the adjacent side, the opposite side, and the hypotenuse. So for sine theta, opposite over hypotenuse. For cosine theta, adjacent over the hypotenuse. For tangent theta, we have the opposite over the adjacent. So for these three functions here or trigonometric functions here, these are the reciprocal of the trigonometric functions at the left po. Cosecant is the reciprocal identity of sine. Secant is reciprocal of cosine, and cotangent is also reciprocal of the tangent po. So nakita nyo naman po yung ating mga ratio. So opposite over hypotenuse, so magiging hypotenuse over opposite. Same with adjacent over hypotenuse, so magiging hypotenuse over adjacent. And for tangent, opposite over adjacent, so ang cotangent is adjacent over opposite po. So ito po yung ating katandaan para mas madali po nating mahanap yung mga values ng six trigonometric functions. We have example 3 here. Given the right triangle below, determine the trigonometric functions of angle A and angle B. So we have here acute A, acute angle A, acute angle B. So the six trigonometric functions with respect to angle A are sine A, opposite of angle A is 3 and the hypotenuse is 5. And then since cosecant is reciprocal of sine, we take the reciprocal of 3 pips and this is 5/3 po. For cosine, the adjacent side of angle A is 4 and the hypotenuse is 5. So to get the value of secant A, we need to take the reciprocal of 4 over 5. For tangent A, so the opposite over adjacent. So 3 over 4. And take the reciprocal of 3 over 4 to find the value of cotangent A po. For the six trigonometric functions with respect to acute angle B, so sine B is equal to 4 over 5. 4 is the opposite side of angle B, and the hypotenuse is 5. And take the reciprocal to find the value of cosecant B. For cosine B, the adjacent side of acute angle B is 3, or the length is 3, and the hypotenuse is 5. For secant B, 5, take the reciprocal of 3 over 5, so it is 5 over 3. For tangent B, the opposite side is 4 and the adjacent side is 3, so 4 over 3. And for cotangent B, take the reciprocal of 4/3, so it becomes 3 over 4, which is the value of cotangent B. For the next example, we are going to determine the other 5 trigonometric functions given the value of secant theta, which is equal to 4. So ito po yung illustration niya. So if we're going to illustrate the given, we have secant theta is equal to 4 over 1. This means that the value of the hypotenuse is 4 and the adjacent is 1 since 4 over 1 is equal to 4. Then we need to use the Pythagorean theorem to find the missing value of the opposite side of angle A, or the opposite side of this angle. So we have here the formula. Since we have the hypotenuse and we have the length of the legs or one side of a right triangle, so we have uh, opposite is equal to c squared minus a squared or b squared depending on your choice. So always po na yung c ang laging nauna. So c squared, which is 4 squared, is equal to 16, minus 1. 1 squared po ito. It should be 2. So 1 squared is 1. So 16 minus 1 is 15. And it cannot be simplified anymore. So we have square root of 15 for the length of this side, or this side BC. Then after determining the length of this side, we can now determine the other 5 trigonometric functions. So therefore, the other trigonometric functions of theta are sine theta is equal to the opposite side, which is square root of 15 over 4. For cosine theta, reciprocal of secant. So since secant is 4, theta is 4, so the reciprocal of 4 is 1/4. For tangent theta, we have the opposite over the adjacent, so square root of 15 over 1 is equal to square root of 15. For cosecant theta, we need to take the reciprocal of the value of the sine theta. So 4 over square root of 15. Since we have here a denominator um, which is a radical sign po, so we need to rationalize the given fraction. So in this example, we need to multiply square root of 15 for both numerator and denominator to simplify the denominator. So we have 4 square root of 15 is 4 square root of 15. And square root of 15 times the square root of 15 is square root of 225. And then we need to take the square root of 225 and its square root is equal to 15. So, recall lang po na kapag nag-rationalize po tayo ng denominator, we must multiply the same value of the same value in the radicand po. So, 15 po. So, for second theta, so given na po siya, so, 4 na din po. For cotangent theta, we need to take the reciprocal of square root of 15 over 1, and we have 1 over square root of 15. So, same process po, when we rationalize denominator, we need to multiply square root of 15 for both numerator and denominator. So we have 1 times square root of 15 is square root of 15. And then, same with the process we do in this uh, value po. So, the value of cotangent theta is square root of 15 over 15 po. Let's have this definition of trigonometric function of an acute angle with the point on the terminal side. So remember that let theta be an angle in standard position with x and y, a point on the terminal side of theta, and let r is equal to the square root of x squared plus y squared. Then we have this following ratio or the values of the trigonometric functions using x and y and r. So for sine theta, we have y over r. For cosine theta, we have x over r. For tangent theta, we have y over x. And for cosecant theta, we have r over y, reciprocal of sine. For secant theta, we have r over x, reciprocal of cosine. For cotangent, we have x over y, reciprocal of tangent. So, in this given example, if r cannot be 0, it follows that the sine and cosine functions are defined for any real value of theta. However, when x is 0, the tangent and the secant are undefined po. For example, the tangent of 90 degrees is undefined. So 90 degrees po is ay quadrantal angle po siya. Nandito po siya. So from here, from this initial side going there, this is the terminal side. So the value of the terminal side line on the y-axis, meaning that the value of x is 0. Similarly, when y is equal to 0, the cotangent and cosecant ay are undefined. So if we're going to observe po, so y minus must not be equal to 0 for cosecant and cotangent para hindi po sila maging undefined po. Let's have this example. Let negative 3, 4 be a point on the terminal side of theta. See figure 6 below. So ito po yung figure. Yung ating point on the terminal side is at negative 3, 4. So we let negative 3 as our x and y is equal to 4. So we have here, and solving for r, we apply the Pythagorean theorem. So r is always the longest. So if x is negative 3, so square of negative 3 is positive 9 na po. And square of 4 is 16. So 16 plus 9 is 25. And square root of 25 is 5. So using the ratio on our previous slide po, sine theta is equal to y over r. So if y is 4 and r is 5, so sine theta is equal to 4 over 5. For cosine theta, the ratio is x over r. So negative 3 over 5. For tangent theta, we have y over x. So we have negative 4 now. Since negative po yun, so we're going to multiply negative to 4 over 3. So ganun na po. In this example 6, we have point on the terminal side, negative 2, negative 6. Find the values of the 6 trigonometric functions of theta. So x negative 2, y is equal to negative 6, and we have r, which is equal to 2 square root of 10. So since negative 2 square is positive 4, the quantity of negative 6 square is positive 36. So if we add 40 and 36, the sum is 40. And simplifying po, we get 2 square root of 10. Sine theta is equal to y over r. So the value of y is negative 6 and the value of r is 2 square root of 10. So in this case po, meron po tayong square root of 10 sa denominator, but we need to simplify first the values outside the radical sign po. So 6 divided by 2 is 3 and copy the negative. Then, same yung kanina po na ginawa natin na nag-rationalize po tayo ng denominator since meron pong radical po sa baba. So, kaya nag-multiply po tayo ng square root of 10. So, kaya naging 3 square root of 10 over 10 na lang po. For cosine theta, x over r, so x is negative 2 and r is 2 square root of 10. So, cancel na po yung 2 over 2. The quotient is 1. So, 1 over square root of 10. And then, nag-multiply po tayo ng square root of 10, both numerator and denominator. Ang nangyari po, negative 1 times square root of 10 is the same as the square root of 10. And rationalize po natin yung denominator, square root of 10 times the square root of 10 is the square root of 100, and which is equal to 10. For the tangent theta, y over x. So y is equal to negative 6 and x is equal to negative 2. So simplifying negative 6 or dividing negative 6 by negative 2, the quotient is positive 3. For cosecant theta, we need to reciprocal the sign r over y na po. So from the given po, negative 2 over 6 is 1/3 po yan. Kaya meron tayong 1 over 3. So it should be negative square root of 10 po. It should be negative square root of 10 here over 3 po. For second theta, reciprocal po r over x ng cosine. So 2 divided by 2 is 1 times the square root of 10 is negative square root of 10 po. Let's have cotangent theta, reciprocal of tangent x over y. So if tangent is positive 3, so we need to take the reciprocal, and its reciprocal is equal to 1/3, which is equivalent to the value of cotangent theta. So that's all for our trigonometric functions. And the next part will be uh, discussed on the other videos po. Thank you.